Hello, I'm William Richardson.
Hi, my name is Gavin Cheung, and we're doing the extra credit for the final exam for CHEM 102. So we're doing this question from topic 7, video E. The question's asking which of the following statements is correct when you compare ionization energy, 1, atomic radius, and electron affinity. So in order for us to answer this question, we need to know the periodic trends. Okay, so let's start with atomic radius. Atomic radius gets larger as you go right to left, and smaller as you go this way, left to right. As you go down, the atom gets larger because with each row you're adding a new energy level. So the electrons are further out, so it gets bigger. And as you move left to right, it gets smaller because you're adding protons, and the attractive charge is higher, so the electrons get packed closely together, or closer together. So the general trend is that way, from biggest to smallest. The next one is ionization energy. Ionization energy is the amount of energy it takes to pull out an electron. And
We know that it becomes harder to pull out an electron when the atomic radius is smaller because the charge on the nucleus its effect on the valence electrons is much greater when you're up here versus when you're down here.
So ionization energy is higher up here and lower down here, so the trend is that way. Next one is electron affinity, and electron affinity is the amount of heat released when you add electron into an atom. Atoms that have achieve more stable configuration when they have an electron added release more heat because the energy levels they decrease. So halogens, when you add an electron, they release an enormous amount of heat because they attain noble gas configurations, which are very stable, as opposed to atoms over here. When you add an electron, they get the electron configuration of this, but they're not as stable, so they release a small amount of heat compared to this. And if you synthesize all that together with atomic radius, electron affinity will be highest here and lowest here, so that's the general trend. Okay, so let's get back to the question now. With what we know, you can automatically rule out B and D, because as atomic radius increases, it'll be easier to pull out an electron. So ionization energy would be lower. So you're left with A and C. So you just need to determine how electron affinity is affected with these trends. So that is actually the equation for electron affinity. So when the atomic radius is big and ionization energy is lower, and you add an electron in, less heat is given off because the electron configuration is not as stable, and so for less heat you'll have a low number of negative delta H, and the EA would actually be less positive. So the answer is A.